So let's talk about the area of a plane region. You may have been wondering, what do you mean by the area of a plane region? Recall that the origins of calculus are connected to two classic problems, the tangent line problem and the area problem. So example 3 begins with an investigation of the area problem. So use the 5 rectangles in figure 6.8 and A and B to find two approximations of the area of the region lying between the graph of f of x equals negative 5x, or negative x squared plus 5, and the x-axis between 0 and 2. So you have this like downward opening parabola. I'm going from 0 to 2, 10/5 is 2, and I want to shade all that area in to make that region. So it's going to be like this region right here. Okay, pretend we could shade all that in. I'm trying to approximate that area. Well, if I make rectangles in figure A, notice I'm using, I go every 2/5, excuse me, and I make a rectangle. So 2/5, 4/5, 6/5, 8/5, 10/5, and I make a rectangle. And notice that if I divide it into 5 different intervals, I'm taking the right side of each interval and going up, touching the curve and making a rectangle. Up, touching the curve, make a rectangle. And notice since the graph is decreasing and concave down, the rectangles fit nicely underneath it. That would yield an under approximation for the area because you have these little gaps here. Okay, these ones I'm doing the same subdivisions, but I'm using the beginning of each subdivision or the left endpoint of each one, and I'm getting over approximations because now the rectangles are sticking out over top. So the right endpoints of the 5 intervals are 2/5 I, where I is 1, 2, 3, 4, 5. So like 2/5 times 1 is 2/5, times 2 would be 4/5, times 3 would be 6/5, 8/5, 10/5, and it would give me all of these x values, just the formula for the x value. So the width of each rectangle is 2/5, and the height of each rectangle can be obtained by evaluating the function at the right endpoint of each interval. So essentially, if you look, the width of each of these rectangles is 2/5. If I do the right endpoint of each rectangle and plug it into this function, I will get the corresponding height of the rectangle, which is also the y value of the function at that point. Okay, I also know the width of each rectangle is 2/5. So if I know the height of the rectangle and the width of each rectangle, guess what I can get? I can get the area. The sum of the areas of the 5 rectangles is the sum of f of 2i over 5. So remember, this 2i over 5 is the formula for the right endpoint of each rectangle, and I'm plugging that into the function to get the height, the y value. And I'm multiplying it by the width of each rectangle. Okay? So the function was negative x squared plus 5. If I plug 2i over 5 in for x, I would get 2i over 5, negative 2i over 5 squared plus 5. That's the function evaluated at the right endpoints. Okay? And if I do the limiting process and, if I plug in the numbers 1 through 5 and add them up, I'd get 162 over 25, which is about 6.48. Because each of the 5 rectangles lies inside the parabolic region, you can conclude that the area of the parabolic region is greater than 6.48. The left endpoints of the 5 intervals are 2/5 times I minus 1. Because if you start at 1 and you do 2/5 times 1, you're actually going to get the right endpoint of the first rectangle. But let's back up a little bit. If you look at these rectangles, they have the same endpoints, but the right endpoint of the first rectangle, 2/5, is actually the left endpoint of the second rectangle. So if I want the left endpoint of the first rectangle, I'm going to have to do 2/5 times the I value minus 1. So if I plug in 1, I'm actually going to get 0, and 2/5 times 0 is 0. So that would give me the left endpoint there. If I plug in 2, 2 minus 1 is 1, 2/5 times 1 is 2/5. Give me this point, but I'm on the second rectangle, so it is the left endpoint, so forth and so on. Okay? Hope that cleared it up a little bit for you. So again, I have 2/5 times I minus 1, where I is 1 through 5. The width of each rectangle is still 2/5, and the height of each rectangle can be obtained by evaluating the function at the left endpoint. So remember, the function was negative x squared plus 5. Okay, so negative. Now, if I distribute the 2/5 through, I would get 2i minus 2 all over 5. That's how this 2i minus 2 all over 5 got in here. So it's negative that squared, remember, negative x squared plus 5. So negative that squared plus 5 times 2/5. If I plug the numbers 1 through 5 in, simplify, add them all up, I would get 202 over 25, which is 8.08. Now, because the parabolic region lies within the union of the 5 rectangular regions, in other words, the rectangular regions over-approximate the area, you can conclude that the area of the parabolic region is less than 8.08. So combining those two results, I know that the area of the region is somewhere between 6.48 and 8.08. All right. See you in the next video.